The remainder and factor theorems. Okay, remainder theorem first. These are pretty straightforward, as long as I can spell remainder. And the remainder theorem just says that the remainder we'll say when using synthetic division, because that's what you would use it with when using synthetic division, is the value P of x. Okay, so what the heck does that mean? Well, it means this. So let's say I had P of x equals x cubed plus 2x squared minus x plus 4, and I want to find P of negative 5. Well, what this remainder theorem says is that you can use synthetic division and find the remainder. The remainder is the answer to P P of negative 5. Okay, so what I'm going to use is the remainder theorem. So I have a 1 in front of that x cubed, I have a 2 positive, I have a negative 1, and I have a 4, so starting synthetic division. What goes in the corner is the negative 5, so you're not taking the opposite. The only time you have to take that opposite is if you have x minus, or x plus 5 or x minus 5 or something like that. Okay, and then so I'm going to come down here and I bring that first number down, it's 1. And then I have 1, and I don't know if I still need to do this for you or not, but here we go, just in case. 1 times negative 5 gives me a new number, and it's negative 5. I'm going to add down, I have negative 3. So then what I have is negative 3 times negative 5, that number for C, and I get a new number, and it's 15. And I'm going to go ahead and add, and I end up with 14, and then I'm going to go 14 times that C over here in the box. I'll get a new number, it's negative 70, and my remainder, which is this last one, is negative 66. So P of negative 5 is equal to negative 66. So that's the remainder theorem. It just says you can use synthetic division, find the remainder, and you have that value, P of negative 5. And I can prove it to you, and I'm going to prove it to you whether you want me to or not, just so you know. But first, I would like to just, the rules here, or the, what you're doing is you need to find the remainder. Find the remainder using synthetic division. Okay, well, so I'm going to prove that this is true. Okay, so we know that before what we needed to do was we would just plug it in, right? So P of negative 5 would equal, and then we would have just plugged it in there. I'm going to scoot this up just a touch so I don't run out of room and forget to scoot it up. Okay, so we would have plugged it in, right? So I would have had negative 5, and that would have been cubed plus 2 times negative 5 squared minus negative 5 plus 4. So that's what I would have had before when we did it. You know, that's, you know how to do that. And then negative 5 cubed is negative 125. Negative 5 squared is 25, times 2 would be 50. And I have a negative minus 5, or the opposite of negative 5, so I'm going to have another plus 5 and a plus 4 sitting there. So what I really end up with is negative 125 plus 59, and what do you think negative 125 plus 59 is? Oh yeah, you're right, it's negative 66. Okay, so P of negative 5 equals negative 66. Typically, synthetic division is just kind of a quicker way to go if you want to find the value, and it's just that, the remainder spot. Okay, this spot right here, this is your value. Okay, that's your value. There it is. All right, let's go to one that you can do. I'm going to have you do it, and then I'm going to go through it really quick. And see if you can keep up with me. So I have to go to another page and find one that doesn't have a bunch of ink all over it. Alright, so I'm going to switch pages on you. And this is continuing. And this is one I want you to do, so you're just going to turn off the video for a second and see if you can do it. The remainder and factor theorems. I should write all this on the top before I start and have all my pages. That'd probably be a smart thing to do, huh? But I didn't do that. Maybe next time. Okay, here's one for you. I just covered it up. Where is it? Here it is. I want to find, well, I have P of x equals x cubed minus 3x squared plus x minus 1, and I want to find P of 2. Alright, you do. Turn off the video and see if you can do it using synthetic division. Okay, turn it off. Try it. If you're just waiting for me to do it and to show you, you're not going to be learning anything. But I can't stop you from doing that, so I'm going to continue on here. You know, the amount you learn is up to you. Not much I can do about it if you don't want to stop the video and try it yourself. So, we know what the result of that is, all right? Okay, here it is. I took the coefficients here. I have a 1, a negative 3, a 1, and a negative 1. 2 is in my box. I bring down the 1. 2 times 1 is 2. Add those together, I get negative 1. Negative 1 times 2 is negative 2. Add those together, I end up with a negative 1. Negative 1 times 2 is 2. Negative 2 rather. Negative 3 then is my answer. That's how fast it can go if you're good at it. Okay, so there it is. There's my answer. P of 2 is negative 3. So it goes pretty fast. Yeah, I could have put it in there and I could have figured it out that way also. But it goes pretty fast using the remainder theorem. So that's the remainder theorem, as simple as that. Alright, next piece. The next piece is the factor theorem. This one's super simple. And we will be practicing this in class because this one is so simple. And a lot of times you guys can't do it, but it's so simple. Okay, here we go. The factor theorem says this, that if the remainder is 0, then it is a factor. Okay, well, how simple is that? Pretty dang simple, right? So the question then becomes, is x minus 2 a factor of p of x equals x to the fourth minus 4x cubed plus 5x squared plus 4x minus 12. If the remainder is 0, then it's a factor, and I'll show you what that means. If the remainder isn't 0, then it's not a factor. So all you're doing is looking for the remainder. Once you find the remainder, you can answer the question. So 0 equals factor. Okay. Not 0. Here, I'll give you that one. Not equal to 0. Not a factor. So let's look. Again, I'm going to do the synthetic division. I'm going to go pretty fast. So just in my box, it's in this x minus 2 format, or x minus c. So I know that I'm going to actually have c is going to be a positive 2. And then I have a 1, negative 4, 5, 4, negative 12. Okay, ready? Synthetic division, bring down the 1. 1 times 2 is 2. Negative 4 times, plus, negative 4 plus 2 is negative 2. Negative 2 times 2 is negative 4. 5 plus negative 4 is 1. 1 times 2 is 2. 4 plus 2 is 6. 6 times 2 is 12. Negative 12 plus 12 is 0. Is it a factor? Yeah, it is. Yes. And what this means is it has no remainder, so this should really make sense to you that it's a factor, because what we would end up with, and I'm just going to try to move this paper up just another touch here. What we'd end up with then is, look, x to the fourth, I'm going to go x cubed. So x cubed minus 2x squared plus x plus 6. There's no remainder, right? So if I were to take this and multiply it by x minus 2, I would get my original. There's no remainder, therefore it is a factor. Okay, it is a factor. So let's say I had factors of 10. Oh, 2 times 5. Notice there's no remainder there. 10 times 1. There's no remainders there. Those are factors. I couldn't go, and I can't do it off the top of my head, but I couldn't use some fraction. Okay, a fraction times a fraction, and that gives me 10. Yeah, I could figure it out, and yeah, I know there's a fraction times a fraction that's going to give me 10. But those aren't factors. The factors are whole numbers, just like these are whole. Okay, so no remainder. All right, so that's the factor theorem. It's pretty simple, pretty straightforward. Okay, we're going to go to the next thing. How much time do I have left? A little bit. All right, new page for me, probably not for you. My pages are smaller than yours. I'm going to try to squeeze in one more piece, and well, no, 2 more pieces. So here we go. The remainder and factor theorems. I'm not going to write the thing on the top, it just wastes time, so let's just keep going. This one is find a polynomial equation. Find a polynomial. Find a polynomial equation with integral coefficients. Make my thing big enough. That has, I don't think I wrote this very well, that has roots, these are the roots, 1, negative 2, and 3 halves. So those are my roots, okay? Those are my roots. That's kind of the base of this. My roots are those. And now I want the equation. Well, you'd really just need to work backward. So if these are my roots, then I have x equals 1, x equals -2, and x equals 3/2. And I'll show you how to handle that fraction. It's not so terrible. And so, you know, if we were solving this, this would be our answer. But so I'm just going to go backward, right? So x equals 1. Going backward, I guess I would subtract 1 from both sides. I'd have x minus 1 equals 0. Okay, so that's working backward. Here I would add 2 to both sides. I have x plus 2 equals 0. And here I would subtract 3/2. Still don't worry about that fraction. Minus 3/2 equals 0. Okay, so then the reality of the situation is that x minus 1 times x plus 2, and then now I'm going to show you that fraction so you know what to do with it, and I'm just going to kind of put a thought bubble over here. X minus 3/2 is the same as this 2 moving in front of the x, so 2x minus 3. Those things are equal. Okay, so I'm gonna use 2x minus 3 in here. Those are the same thing. So, and that equals, this whole thing would equal 0. Okay, do you see how we're working backward? So I'm working backward. Usually you would go this way. You would have factored something and you would have got these as your factor, and then, oh, what does x equal? Oh, well, x minus 1 equals 0, you know, that zero product property, and then you would have solved for x. But I'm going backward, and now all I have to do is multiply that together. Okay, so multiplying this thing together, I'm just going to, you know, pick 2 of them to start with. So I would have x squared. I have negative x plus 2x. That's going to give me a plus x minus 2, and then I'm going to have to multiply that by this other guy. Okay, so I'm just going to distribute them. So 2x times x squared would be 2x cubed. 2x times x would be plus 2x squared. 2x times -2 would be minus 4x, and then I'm going to go with the negative, -3. -3 times x squared is -3x squared. -3 times x is -3x. -3 times -2 is a positive 6. Yeah, there's like terms there if you see them. This is a squared, even though on my paper it looks kind of ugly, but that one and that one are like, and these two are like. So I'm just going to combine those like terms. My answer is 2x cubed minus x squared minus 7x plus 6 equals 0, and there's my answer. Okay, that is what I was looking for. A polynomial equation with integral coefficients that have roots, has roots, I don't know, bad English, 1, -2, and 3/2. Okay, so you're working backward. So work backward. Okay, so x equals whatever, right? Work backward from x equals. And then you have to multiply them out. So there would be my 1, there's my 2, and you're going to have to look here to figure out what's going on. Okay, so that's when you have roots, you're working backward. They take practice. Okay, and then we have one last little part. Okay, the remainder and factor theorems. Okay, I don't have much battery left. Solve. Given one root. Okay, these are a little confusing at first, but they're not really all that bad. So you're given a root. Well, if you're given a root, then that's really your c, right, that you could put in that corner. So I do have 1/3. Now don't be afraid of fractions, they'll all work out in the corner there. And what I'm going to do is use synthetic division to get me into a squared, x squared, something squared. So I'm going to say 3 minus 1 minus 18 plus 6, right? Bring down the 3. 3 times 1/3 is 1. Negative 1 plus 1 is 0. 0 times 1/3 is 0. Negative 18. Negative 18 times 1/3, well, 18 divided by 3 is 6, and it's going to be negative, so negative 6. There is my remainder is 0. Now, if you get a remainder that's not 0, then this process is pretty much over. You can't do it. So what I have here is I have x cubed, so that's going to go to 3x squared minus 18, right, because it's the 0x, equals 0. From here, I'm going to have to factor and solve, and that's all you have to do. So here's my number 1 is use synthetic division. To find an equation that's x squared. And then 2 is factor, and you know how to factor, so you're going to have to factor this guy. Okay, so I'm going to add 18 to both sides, so 3x squared equals 18, divide by 3, x squared equals 6, square root, that gives me that plus minus, x equals plus minus square root 6. So what are the roots? They are 1/3. One of them is negative square root 6, the other is positive square root 6, and those are my roots. Okay, so I've given one root. So they gave me one root, and I can find the other two. All I have to do is use synthetic division, and then factor. Okay, so synthetic division is my step that gets me to that x squared one, which I know how to factor. I've got all kinds of tools to factor something that's a x squared equation. All right, and here is one for you to do. I'm just going to put it right here. Why don't you try this one? Okay, x cubed minus 2x squared minus x plus 2 equals 0. The root is negative 1. So go ahead and try that one, and we will talk about that one in class tomorrow. All right, I think we're good.